Hi everyone, this is Introduction to Data Mining. I hope you are excited to start the journey in this course. This is Dr. Abdul Karim Kanan. What is data mining? Data mining simply is a process of discovering useful information and pattern inside the data. So for example, if you want to do some prediction, let's say about whether a rocket will land or not successfully back to the Earth, then what do you need to do? If we talk about the traditional programming and comparing it with data mining, then there is a lot of differences in their concepts. The traditional way of programming, where you suppose have already been experienced, where you define variables and you do some checking on data or values, let's say temperature or age or the field of name, and then based on it, you take further decision or action. So for example, if you want to force the user or to check on the user whether he has successfully entered some input, then just you define some variables and then you check the values of these variables to ensure that the users have filled up the information, right? And then you may take a decision based on the entries that the user has made. Let's say another example, if the user has entered his age as 200, then you may decide to give him a warning message saying it's invalid input where he needs to make a correction, right? Or probably you can take a decision if his age in between a certain category to decide whether the user is a child or adult and etc. So we all aware of that, right? This is the traditional way of programming. We have variables, we have decisions to make to control the flow of a program. But when it comes to data mining, the concept is different. You don't go just simply to a particular field, let's say inside the data sheet or the data set available at your side, and based on it, just you take a decision, right? You come up with a prediction. It's not like that. It's not the same way as traditional programming. In data mining, so if you check this definition, it says a field of study that gives computers the ability to learn without explicitly programmed. So what does that mean? So that means you try to use some other techniques, let's say such as statistics, in order to take a decision. We will see that as we explore or dive further in this course, but just to make it simple, at least to draw a line between traditional programming and data mining, assuming that you are interested to predict the price of a property, right? So one way is maybe probably you check the old data and take the mean value, right? You calculate the average. So as simple as that. But this might not be accurate, right? Because if you need to consider a lot of factors, that may be the location of the property or the premise, right? And then the season, whether it's the time where people purchase more, is it near to the city center, is it far, and etc. So if you take this example and you try to solve it using traditional programming, so you need to have a lot of if condition, right? Actually, this can be one way. So you say if this variable, the location is near, if the house has 4 or 5 rooms or less or more, and you keep doing this, but at the end, of course, you will get very complex application. Now, alternative solution is where we apply data mining. If we can find a line, let's say, you know, mathematics, right? We know about the equation of a line where we have a coefficient and we have the equation for the line, right? And then if we can find a line that can fit this data, so that means we have like come up with a summarization with a fitted line for all these data, no matter what data you have, number of rooms, the location, and etc. Then if I can come up with, let's say, an equation, so what you need to do, if you have an equation and you are looking for y, right? Usually the value that you are calculating is y. So what do you need? Only you need to substitute the values for x. So x1, x2 will be those factors that just we were discussing, like the number of rooms and etc. And y will be the predicted price for that property. So I hope now at least you can draw a line when we talk about the traditional way of programming and when we compare it with data mining. How is different? Here we're working on mathematics, statistics, while there is just directly we go and check on variables and we try to take some decision. Generally, we have two types of methods or tasks that we do in data mining. We have prediction method, where we use some variables, right? Like the example I mentioned earlier, when we are trying to predict the house price. So probably we take the number of rooms, the location, how far it is or near to the city center, and etc. So we take all these are called variables. So we take them into account in order to predict the unknown, or actually, in other words, what we are trying to predict. For example, the price. Okay, then will be the unknown. So we try to predict the unknown or future values of other variables. On the other hand, description methods is where we try to find the human interpretable patterns that describe the data. For example, we may plot a figure to find if there's any pattern or relation, for example, between the shift gear or the gear shift type and the car price. There are many types of operations or tasks that we may intend to do in data mining. For example, we have predictive modeling. We're going also to talk about clustering, association rules, and anomaly detection. So what do we do in prediction task? In prediction task simply is we try to find a value for the unknown. For example, we're trying to predict the car price based on other variables. Or we may try to predict whether the type of animal is cat or a dog. This is another way of prediction, another type of prediction. So there are predictions simply is where you try to predict the unknown. If you take this into as an example, like we're having here a list of data about the employees, like whether the person is employed or not, the level of education, the years at present address, credit worthy. So, and the red column, if you check here, is the one that we're trying to predict. Well, now you may tell me, sir, we have the data in here, right? It's already provided, yes and no, no, yes. Of course, it's here for now. But for any future, let's say, record, we might be interested to decide whether this is a credit worthy or not, if the person is a credit worthy or not, right? So this, let's say we found out later, but we need, if we are able to predict in advance, that would be useful. So prediction simply where we try to find the unknown. Where in sales promotion or where we try to apply association analysis is different. In this example, we try to find the connections, let's say, between some products and other products. So for example, we try to find if a person buy a bread and butter, okay, then we need to find what is the probability him buying milk, for example, right? Or if he buys milk, what is the chance he will buy diaper? And all this information for association can be useful for sales promotion, shelf management, and inventory management. Another task of data mining is clustering. So in clustering is different than prediction and association analysis. In clustering, we try to group the data together. So in other words, we try to identify a group of points that belong to each other or that are similar to each other than other objects or other data points in other groups. What are the types of machine learning systems or data mining? We have supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. But what does that mean? It means when you are training your model, when we come to train the model to build the model that is going to do the actual work, for example, prediction, then we need to follow a way. We need to know how these models can be taught. So what is supervised learning? So as the name indicates, there is supervision, right? So in other words, as you see here in this example, inside our data set, we have different instances, and assuming that we are interested to build a spam filter. Now, we are aware that inside this data set, there are some spam emails and some of them are ham emails. So as you see, each one got some label as an indicator whether it's spam or non-spam. So in this way, while the model or while the algorithm is being conducted, it will take this information into account. That means it will consider whether the email is spam or not. Okay, so keep that in mind. That means while it's working, it's looking into what type of email that is being worked on or that being used to train the model. So this is called supervised. Here is another example of supervised learning. As you see here, the y-axis is the one that we are trying to predict, for example, is the value of something. Let's say the car price. And now again, as the algorithm is being working, it will take into account the value presented on the y-axis. So simply this information is considered. Like if I come to you and I tell you, you need to identify or find, let's say, the work or the student who got high mark or low mark. Then you may ask me, how could I know? I tell you simply, there is a label, or I already have kept a note on each paper saying whether this is high or low. Okay, so now while you are, let's say, classifying these papers, you're just simply taking into account the label. Right, so this is again called supervised learning. While in unsupervised learning, the situation is different. Now, assuming we have a group of people and you want to learn something about them. You notice here, I'm not telling you, for example, you need to predict the income of these people, right? There is nothing in particular I'm pointing to that you need to learn about. But simply just I'm telling you this group of people, you need to find or you need to group them. So what do? You try to find similarities between these groups and then, or between these people, and then you group them together. So the way of being learning or the way you learn is different than in supervised way. So there's nothing here in unsupervised learning. We don't have a specific thing we are targeting. We're not looking for a specific feature to predict or to the unknown to know or to predict, while we're trying to identify similarities between groups of data points, and here in this example, groups of people. So here is another example we have as an unsupervised learning, and the objective is to find the anomalies inside the data set. So this is also considered unlearning way, right? So you will try to find where the majority are, to learn about them, and then you find those that makes exceptions, right? So you try to identify those that make exceptions inside your data, and those are the anomalies inside your data set. Applying semi-supervised learning means that you have data that is mixed with labels and unlabels, right? So labels data usually is useful when we are conducting supervised learning, while unlabeled data is useful, or we use it when we are conducting unsupervised learning. right? But how about semi-supervised? So semi-supervised indicates the data are mixed, or generally you can say you have the majority unlabeled data and few labeled data. And some algorithm can work with this kind of data that is partially labeled, and this is called semi-supervised. Now, in reinforcement learning actually is quite different than the others. So here the concept is based on the idea that there is a reward and penalty. So in other words, the algorithm will work, and when it does something good, it will be rewarded to continue. And when it has committed something bad, then it will be penalized, right? So that means it will try to find another way or to adjust its way in order to become better. And this kind of learning system called an agent. So this kind of learning system is called an agent that usually used to observe the environment. Other types of machine learning are two: instance-based learning and model-based learning. Before I go into details, keep in mind that all the time, machine learning, the important thing in machine learning is we try to generalize. Meaning, what does generalization mean? So generalization means that the model has worked well in order to be used for other cases, for unseen data, for new cases. For example, we are doing prediction. So we teach the model in order to be so good to be used to generalize. So we have taught the model on certain types of data, and now we are interested to take this model to use it for other data that this model hasn't trained on. Now, if the model does well on unseen data, so that means the generalization was good. The output of the model was good. Otherwise, if the model doesn't perform well, that means the model wasn't able to generalize. That means the step further is not able to go a step further. Probably he learned about the current data that is presented to him, but is not able to go further step to do a good job on unseen data. Now we come to the types of instance-based learning because it's related on how these models or the data mining algorithms generalize. So instance-based learning simply has another terms which is called memory-based learning. And this type of algorithm that is considered instance-based learning, such as k-nearest neighbor, decision tree, these algorithms, instead of coming up with a model with something that can be used later to predict on the unseen data, they take the new unseen data and then they go to compare it with the instances seen inside the data set, inside the training data set. So for example, k-nearest neighbor, every time you give it a new instance, a new case to work on to predict, it will take this instance and go to do some calculation, taking the new data with all other instances in the training data set, each and every time. So this kind of algorithms is considered memory-based learning, right? So instead of coming up with explicit generalization, like saying any person with these values, for example, will be considered as this type. No, it cannot come up with something like this, cannot come up with explicit generalization. And instead, every time you give or you pass to these types of algorithms a new instance, it's going to compare these instances, the new instances, with the seen training data. So it's going back to the training data set and do comparison. While in model-based learning, so simply they come up with explicit generalization. They come up with a model that is able to generalize. Like for example, if you take the equation for a line for regression, then this is a model-based learning because simply I take this information about this model, which is represented by a fitted line, and then just I substitute the value of the features for the new instance for the unseen data, and it will give me y. I don't need to go back to the training data set and do anything.